Hello, today I'll present this paper with the title discussing an adversarial parrot trained technique for adversarial attacks against audio recognition models. So first I'll discuss what is audio recognition or speech recognition models and what is adversarial attacks against these models, what are the existing black box attacks, what are the challenges and why we proposed or why this paper proposed the parrot training attack, and what is the challenge and how it is addressed. And in the end, I will show the experimental results. And finally, we'll conclude. So speech recognition models is used to identify the person who is talking, like a person's, it inputs the original speech and output the name of the person who said the speech. For example, Alice said some voice note and just the model output that this is Alice. It is used in smart devices like Amazon Echo, Google Home, Siri. And the problem is that these models has vulnerabilities, and there is like adversarial examples that can attack. So which we'll discuss. So the adversarial means like enemy or something like dangerous, something malicious. So the goal is to mislead the recognition model, and this is done by modifying the speech. So adding we can call it noise, it's called perturbation to the original speech and generating another speech. So instead, the model, instead of identifying it as Alice, it will identify the speech as it is Bob who is talking, not Alice. So there is existing at a black box, there is white box attacks. This white box requires, white box means we have full knowledge of the target model. And there is black box attacks. It requires only limited knowledge. So we are discussing now the black box and how we modified the already existing. So the already existing black box attacks, which requires no knowledge. So how it's performed if there's no knowledge of the target model, it's use a technique called probing. So the attacker sends a voice or the speech several times, and measures the score until he gets some knowledge about the internal model and can perform the attack and succeed. So so as you see, the probing, there is a problem. There is multiple, large number of interactions. It requires a lot of labor, a lot of time. So this is why we modified. So this is the challenge. So the challenge, we want to minimize the knowledge, knowledge for the attacker. So this is our challenge, but there is challenges, or this is our goal. But to perform this goal, there is other challenges where we don't have training data sets, the model architecture, we have no knowledge, and the parameters. So this is our the technique the paper proposed. It's called Parrot training technique. Parrot, it's the bird that produces like speech similar to the human. So this is a workflow. First, there is three, as you see, there is three parts. First part is a parrot training. So a speech is, for example, it's minimum knowledge means just a very short snippet of the speech, like 8 seconds. So it's the model is trained until and trained and tested against or tested by using different models. The second part is then the AE is generated. AE means the adversarial example, and then the adversarial example itself is tested and added to it like something from the environment, like wind, barking, typing, and then tested on the over the air for the smart device like Amazon Echo or Google or Siri. So let's discuss the first part. So there is training data sets, and there is voice, there is the source, and there is the target. So the source is Eve, for example, and the target is Bob. Target is means that like the impersonation, like someone wants to impersonate Eve. So we want the model, instead of saying Eve, it says Bob. But taking it to, so we have to select, first of all, we have to select the source speaker. So how to select the source, the Eve source speaker. So this selection is done by pitch frequency. So we test the pitch over a lot of various models, and then this is the minimum, choose the minimum one. And based on the distance level also. The second part is the iterative, like choose how much will iterate. So source speech and there is target speech, and we keep iterating until minimizing the ground truth model. Ground truth is the distance from the correct answer. So how to generate the adversarial example? There is attack algorithm AI generation. So we have to take into consideration two things: perception and transferability. And this is called feature twisted environment. So what is perception? Perception is that the human will not know that the voice is modified. Like I am talking, so the human will say, and will generate an adversarial example. So the human will say Hisham is talking. However, the model, we want the model to say it's, for example, Bob is talking, not Hisham. So the human perception model, to do this, we recruited volunteer, or the paper authors recruited 30 volunteers, and then they ask them, like they show them the original and perturb it, and then tell the volunteer rate from 1 to 7 the similarity. For the transferability, so the transferability, we measure the noise, the feature twisted carrier, and the environmental sound carrier. So we take into consideration noise, environmental, this type of. There is a lot of model architectures, different models like TDNN, CNN, various parameters, CNN1, TDNN1, CNN. So there is a lot of these are taken into consideration. So what is the challenge in Parrot training is like to manage the trade-off between transferability and quality. This was addressed by a frame called TPR, transferability perception ratio. Then we got very good results. The attack success measured by the attack success rate. For example, the last smart devices, different smart devices like Amazon, Siri, Google, and we measured the results. Attack success rate was improved by 264%. Human perception was improved by 11% in SMAC, and in QFA's A2SR improved nearly 96% attack success rate and 45% human perception score. These also are the results testing on different distances from 0.25 meters till 4.0 meters, and testing the like impersonation, like Bob wants, the target is Bob, the original is speaker. So Bob wants to impersonate Alice, and these are the, like, this is taken into consideration, it's intragender, not intergender. Like Bob is male and Alice is female, and these are the rates which are very good. So in conclusion, this paper proposed a new technique called Parrot training attack, and it minimizes the knowledge requirements. Like the attacker doesn't have to know much knowledge about the model and the parameters and the internal parameters of the model. It's proved that it was very effective against black box models, and also it maintains the quality, and which we evaluated the trade-off, and we take into consideration this trade-off between transferability and human perception. We evaluated over several over-the-air scenarios, several smart devices, Amazon, Google, and Siri, and it proven very good. Here are the references, and thank you very much for listening to my presentation, and goodbye.